Okay. So all I've done so far is drop the part in. This is actually version 2, so this is one of the harder ones. Well, it's one of the harder assemblies for R2. We've been making all the R1 parts so far. The only difference between R1 and R2 on this is some live tooling milled flats on the hub side of this. Otherwise, you've got 2 1/4-20 threaded ends on both sides, and there's really not a whole hell of a lot to it. We haven't done a lot of lathe stuff, so this is probably good again just to pop through it. The next couple of weeks are lathe and C-axis combination milling stuff, so we'll be doing this at least for the next 2 weeks in a row anyways. So the way that we're going to process this part is in Op 10 is where we're going to do the live tooling, okay? So as far as the part orientation goes, you kind of want to set that up in advance and know when you're doing that milling. Because obviously, if we're coming from this direction, you need a longer end mill to process this flat. And actually, you know, you might have a chance of actually rubbing the top of this OD here if you came from this side. So we want to make sure that this is basically set up on the end that we want to machine first. So the first thing we're going to do is basically flip this thing over 90 degrees so that the flat is facing the right direction, okay? It might be easier to set up the lathe machine group first before we do any moves, just to make sure we have our right orientation too in the D and Z plane. So I'm going to go and make sure I grab my machine group. I tried this with lathe default, and the C-axis stuff is still active. So you should be able to do this at home, even if you don't have the STCC post. But I do want to make sure that if we're in class here, if we do it the right way, we want to make sure we grab that. Let's take the 4X. So the stick mill 4X, okay? The 3X can probably do the same thing because it's not really, live tooling is not really a very complicated fourth axis. I think this 4X actually has like a table on the bed. But what you want to check for and make sure you have before you do anything is you want to check the multi-axis options. And I want to make sure that we have what we want. And actually the 4X doesn't have what I want. I don't see it anyways. So let me double check real quick. Double check something. If I go to the 3X. If I go to default, where is it? What I'm actually looking for is just a simple C-axis stuff, and I don't see the C-axis on here. Oh, you want to know why? I think I know why. I'm in mill here. I grabbed the wrong lathe group. I mean, I grabbed the wrong group altogether. Let me restart this. Oh, don't save. All right, sorry. Machine group lathe ST20 is what I meant to say. I got milling on the brain. So lathe ST20. And then what we're looking for is to make sure we have the C-axis there when you're looking at the turning portion. So lathe, turning, C-axis stuff. If I screwed you up and you grab that mill, just do file new and restart your file. So that the C-axis work that we're going to be doing is basically the face contour stuff, which is easy. You'll notice we also have some face drilling, cross-hole drilling, and we also can do some C-axis pockets and things, which we're going to be doing on the wheels later on. So I'm going to merge that part back in. File merge. KM2 spring. So since we already had this file started, make sure you do the merge and not file open, because then you have to repick that again. Oh, there it is.
Hey, Sean, at home, all we have is
Yes.
the default, right?
Lay default. Yes. Yeah. And I tried that last night, and you should have the C-axis in that still. Is that correct?
Okay, I'll check it. I'm just getting to it now. So
Yeah. Sorry, that's what I meant. Yeah. So if you do lay default at home, the C-axis was still in there when I did it yesterday.
okay,
Because you're right. I
thank
want
you.
to double check it and make sure. Okay. Perfect. So with the machine group selected, now we're going to rotate the part. We're going to rotate it twice actually, and now I'll show you why in a minute. So I'm going to start by flipping this over 90 degrees, and that transform translate is perfect for that, like, or that dynamic, I mean, is perfect for that. And this time I'm actually going to select the center line of the part. You know, normally we just kind of pick off in space and let it flip. This time I want to be specific about how we do this because then it saves us some moves later on. So when you do dynamic translate, the first thing it does is ask you to grab the part or any part that you're going to flip or move, manipulate. I'm going to select that and hit end selection. And then I want to grab the center of the part in the back where we're going to rotate around, because that basically means we're going to flip it 90 degrees to keep that spot at 0. And that way we won't need to do a move to origin after the fact. It'll still be right there. So I'm going to zoom in and make sure that I get the center point. All right, that's the O snap that you want. It's a circle with a crosshair in the middle of it. So we got that. And then this particular flip, if you look at the gnomon, we're going to use the axis between X and Y, and that's going to be our rotation. So it's blue. If you click on any of the blue line segments, you can see that we have the proper orientation. And then you can kind of infer that the move that we want to make is a positive 180. We're basically swapping it over to the other side. So I'm going to type in 180 and hit enter. Check my preview and make sure I like that. And then I'm going to hit enter again. That's basically exactly what I want. So I'm going to click OK. And then I'm going to reset my view by looking at top. So basically, if you rotate that way, your 0 point on your part should still be on the end. Always able to flip it around at that point. Basically. And again, the reason why we're doing this is because we're going to be doing this milled flat on our op 10. So we want to have that side exposed to start. Check. Okay. So here's the blueprint. All right. So again, we're looking at the other direction now. But so we got a 1/4-20 on each side, basically. And we're going to rough out this part on both sides. So we're going to do a flip and have an op 20. So we're going to do a stock flip towards the end. There's not a lot of real funky geometry here. We're just going to have roughing passes and finish passes. Okay. We'll talk about making sure that we machine out past the end of our profiles with our lead in and lead outs, the extensions that we did a couple of weeks ago. And then we are also going to talk about cutoff, and again, we'll talk about the part. So I do like to have, you can have this area, you know, since the lathe, you can have that milled flat in any orientation. I like to have the flat kind of facing me. It's just my personal preference. It doesn't really matter when you change this thing where it is, but I like to work this way versus this way. I don't really know why. It's kind of personal. So I'm going to do one more rotation, and we're just going to do it in a different axis. So we're going to leave it on this side, but we're going to rotate basically around it at 90 degrees too to get that facing us. So I'm going to go back into dynamic again. I'm going to select the part. I'm going to end that selection. Now I need to look at it end on a little bit. So I'm going to rotate so I can see my 0 point again. And I want to snap to the end of that part where the circle is again. Just make sure you get the right O-snap. So there's my O-snap indicator. And then this time it's going to be a Y to Z move, which is the red arc on the gnomon. So a red arc on the gnomon. Check which distance. So it doesn't really matter in this case which way I go. I'm going to do a positive 90 just to rotate this around. So again, I'm going to hand type that 90, enter, enter again, and then confirm. So now when we reset our top view, we're going to be looking at the flat kind of on and this direction. Okay. Again, orientation is not too big of a deal. I just like to kind of look at it like that. When we perform the chaining operation, we're actually going to be chaining the line in the front here. So you'll kind of see how that's a little bit awkward because of the way the radiuses end up here. So I'm going to first go back into my planes and just double check and see where my DZ is. It should be lined up where we want it. If it's not, we'll just do a simple move to origin. The way I'm going to check is by hitting the, highlight D plus Z plus, hit the red equal sign, which will bring all of our views or all of our planes down to that view. And then if you click on G, that's graphics view, it shouldn't change from top to side. It's all the same, basically. So it looks pretty good. I normally have us copy and rename planes, right? For now, we'll use this plus D plus Z. We could copy it and call it Op10. For lathe, it's not as critical as when you're doing milling because there's really only one way, there's only one plane that we're working in at any given time here. So it's not as concerning. What I do find confusing and what I don't like about the other files that I see during the day is they don't tend to have like a real WCS for like Op20. What they do is they like flip it over and wherever their work holding becomes their 0. So if they're up against the shoulder or something like that, that's kind of like their 0 point and that's where their plane is. But that makes the numbers kind of awkward. And you'll kind of see it when we go to do the threading on the other end, instead of going like -3 point or -0.35 or whatever from the end here, it's like a 600 value because it's actually based off of this shoulder up here. You'll kind of see what I mean when we go to do it. If you do an Op20, you touch off the front of the part again, that's 0, and your numbers all kind of line up. But I think it is more work because you do get touch off twice versus where if you just hit the, if you just blurb up against the shock or whatever you're using for work holding, then you know where that is, so you don't have to touch off that part again. I think that's kind of what they're trying to get at when they're running these parts. So that's good. We'll go to levels and double check. So we only have the one solid entity. And again, I also double checked this last night. So we're going to use solid chaining on this part. I confirmed this solid is good. We don't need to do any of that wireframe spins. I mean, that stuff all should work pretty slick. In the past, we've had to do some fancier stuff with wireframe to get the chain to work. So I think that mostly had to do with an old SolidWorks format. This seems to work fine. So I'm going to rename this solid. I'm just going to call this Op10 part, or you can go Op10. And this is the front axle, car front axle. There's nothing saying you couldn't make some wireframe geometry right now if you wanted it, but again, unless you're having issues later on down the road, you can probably wait to do it when you need it. Make it a little confusing if you got a bunch of entities on there that you don't need. I'm also going to right click and clear colors while I'm thinking about it, so it's not purple anymore. If yours is hung up on that, it makes it confusing sometimes when you're trying to select things. So now we can start. And I don't have an op sheet for this one, but we'll review what we're going to do. And I'll give you the stock size. So, we're going to set up stock first. standard operating procedure, so we're gonna leave 30,000 to face off over here. We're assuming this is the saw cut edge that we need to square up. So we're gonna machine our 30,000. We're gonna rough from the stock down to the largest diameter, and we're gonna leave 20 thousandths on diameter, so 10,000 on the side for finishing. And we're not going to do any undercuts with our roughing tool, just like we talked about in the past. We're gonna set that so that it only performs straight cuts. So what that means is we're gonna get to this point here where the flange is here, and we can go back and you go past it, but we're not gonna try and machine any of this stuff because the angle of our tool is not going to be able to get into these features. So we're gonna need to do a flip to get that, okay? Now the relief for that front thread is, we probably could get that with a roughing tool, but we're gonna do that with a finishing tool just because it's got a more aggressive angle to it. And you have more of a chance of getting back here. Usually it's the leading edge that kills you if you're trying to get into a groove like that, because your tool can't drop like straight down most of the time if you got an angled cutter. So that's why most of the time we have to wait for finishing to get through that. Or we have to use a grooving tool for sure. Yeah, how are you? It's okay. Okay, so let's start with the stock. We're gonna do it the margin way, only because I'm basically copying what we did for V2 during the day. I don't necessarily like to do the stock this way, but it's good to see that you have two different options. So inside a stock setup, the first thing we always want to check is that stock plane, right? So by default, it's on top. Top visually looks the same as that D plus plane, but that's not what we're using. So if we don't change this, we're going to get an error when we try to do this. So we want to make sure we change that to D plus Z plus. Okay. And then we're going to do our stock geometry first, and then our chuck jaw and work holding second. So to do that, we're going to go into properties, which is next to stock setup. And again, it's fairly straightforward. The only other difference here is that, they have margins. They're using margins to get that right hand offset, whereas I normally just offset the Z minus and call it a day. So what we're going to do is we're going to do a 1.5 inch OD. Oops. There is no ID, and we have a length of 1.6, which is kind of an oddball number too. So this window, if you go to machine group properties, stock setup, you may have to open the plus button next to properties. You did what I did, so you're no. So we might have to save. So okay, yeah, so just go up to machine group there. I did the same thing. Go to lathe. And ST20. No, don't worry about it. Now that you have that second grouping, you can go to the first one. You just take that and then property. Yeah, so you can. And then we hit properties there. I did the same thing, so don't feel bad.
Is that week what?
This is week 10.
Week 10.
Yeah, week 10. And like I said, this won't take me all night, so we can go back and go over some stuff too. So our diameter is 1.5 inches. Our length of the workpiece is 1.6. And like I showed you in the past, so the way I like to do it is I would normally, add my 20 thou to the length or whatever, and then do a Z move to kind of offset that position. In this case, we can also do a use margin. So when you click on that, it gives you OD margin, right and left. And if you add a right margin of 0.02 there, that also does the same thing as that, as offsetting it in the Z. And you should see that on your screen. So the lathe stock actually increased itself on the right-hand side by 20 thousandths when he did that. See that? So same, two different things. You can use the same things. It doesn't really matter too much. So that's good. So you'll notice that we have a little bit of stock for holding back here, and we have that 20 thousandths for facing. Now we're going to click OK on this to confirm the stock geometry. And now we're going to go back into the stock setup box and go to our chuck jaw properties. So chuck jaws, properties, we're going to skip by geometry and go straight to parameters, because parameters has where our work holding, where the meat of our work holding happens. So we are going to grip from the outer diameter of the stock, right, which we know is 1.5. We can also click on from stock under position, and it's going to read our 1.5 inches. However, what we want to do is actually specify a farther Z distance away, which is kind of oddball for me. This is kind of like, you have a 1.6 inch work envelope, but this is basically saying there's going to be more bar behind it. But it's a way of showing the whole bar sticking out without having it all in the back. I don't really know what the purpose of this is, but you'll see it in a second. So instead of doing from stock, we do user-defined position at 1.5 inch diameter and a Z of -4, -4.0. So that basically pushes the chuck 4 inches away and leaves us a gap in between. So when I click OK here and OK here, you'll see that the chuck isn't actually on the body of the part. Whereas I would normally set the stock up and say, okay, I'll say the length is 6. So we see that extra chunk in the back. But when you're simulating this, you don't really need it. So I guess that's basically what they're saying is, this is basically our cutting envelope, and they don't care about what's going on in the back necessarily. Okay. Kind of a shortcut that I feel like you don't really need. But so for your and for what you got over there, you got a little bit extra. We go back into the top setup. And then just go to properties and stock for one. Yeah. Okay. And then you want to write, okay, so you got a left margin there. 1.2, that should be 0. Okay. And your right margin is 0.02. So basically 20,000 for the right. Right. All right, and again, the other thing is too is I've talked about this in the past too. Normally I would choke up on this as much as possible too. So in my opinion, just looking at this, if this was set up like this in the lathe, I would definitely be choking up on this. I'd pull this part all the way in. But I want to walk through it exactly like they do, because they generate a G code off of this file, so I want to match everything. All right. So now that we have this set up over here, we can start looking at machining toolpaths, basically. We're going to start by facing, as I mentioned, and we already know that we got 20,000 years to remove. Okay. We're going to do it all in one pass. We don't really need to do anything cute with that. So we're going to, let's save it first. We haven't saved it yet. So I'm going to do a file save. And you can save this wherever you'd like. You're going to submit this at the end. So do whatever you normally would, as if you're working on a homework. And now we'll go straight into facing. Okay. So inside of lathe turning, we'll go to face. One of the easiest operations to run in all Mastercam, which is nice. Excuse me. So you at home, Matt, by the way, if you're going to be using the same tool library that I did, which is the default one, you're going to have an issue with one of the tools later on. But I'll tell you how to bypass it, okay?
All right.
For now, you just want to find a roughing tool. So for us, it's T101, the 55-degree right angle. I think you've got like a 50, something like that in the default tool too, so should be fine.
Okay.
So for a comment, again, we're just going to put in here that we're removing 20,000. We're going to say face to clean. Removing 20,000. Can also say establish Z0 if you want to. Yeah, establish. Good stuff. Fees and feeds all come from the tool, so we're all good there. Over in face parameters, there's really only two things we want to look at. We want to make sure that we use the stock. So it's going to actually read what the stock diameter is, and that's going to be where the start of the cut occurs. And again, you can look at the graphic. It shows you a really good representation of what this is going to do. So that shows us that there. As far as everything else on the right-hand side, the defaults are pretty good. If we had more than 20 thousandths to remove for some reason, and you wanted multiple cuts, you could add a rough step over there and a finished step over. For right now, the only thing that we want to do is that overcut amount. We do want to add a value there so that we make sure we go past the center of the part a little bit to remove the nipple in the middle that's going to stay there if we don't go past it. I usually go, 10 or 15. You can just do 0, 1, 0, something like that. It doesn't have to be much. Even 5 thousandths would probably do it. It'll take that small piece of material off. And then the retract and the stock to leave and all that, we're going to leave that alone. So all that looks good. You can click OK. And we end up with our one pass, right? So it automatically calculates where the stock was. I'm going to back plot just to kind of watch it. The tool is going to come from quite a bit of ways. So when you start the back plot, you can press S once, and that'll bring it to the point where it gets to the part and you can actually watch the cut happen. Nothing saying you can't watch it travel in from home, but it just takes a while, that's all. And that looks good. And again, because the lathe post is a little bit smarter and easier to deal with for Mastercam, the stock itself also auto-updates. So you'll see that our gray stock profile is now missing that 20,000. Just for reference again, so if you drag the red insert flag up above number 1 now, you'll notice that the stock updates back to the way it was before that cut happens. So again, keep that in mind. If you want to follow it step by step, that insert flag also updates the stock when you move this, which is kind of nice to remember if you want to see what's happening. At this point, we can rough. And again, we're basically going to rough to that 1.6 area and stop. And we're not going to let it dive into any of the grooves or other areas that aren't in a straight line. So we're going to go up to roughing. Now, this is where the solid chaining is nice when it works, right? And actually this, now I know why I like doing this. So if we hadn't have rotated that flat out of the way, the chain wouldn't have worked as well because it would have seen the flat versus what we're going to do now, which is just chain the OD over that flange. If the flat was there, I think it tries to show you where the round edge is, but this is pretty slick because now when we just change it to solid, we don't have to worry about that flat. It's not in our way when we're chaining. So we did lathe rough. I'll start that again. Lathe rough, solid chaining mode versus C-plane. You can see the difference. Now, when we're in solid chaining mode, it basically always wants you to click the start of your profile chain and the end. So I want to make sure that you grab the bottom of these chamfers. And what I mean by that is, you don't want to click up here because your tool is going to want to start up top. We want to click closest to the end. So I'm going to click on the bottom half of the chamfer to get my start point in the front. We're going to zoom back out. And then we're going to click the bottom half of the chamfer at the end. And then we get a nice chain all the way through. It looks something like that. Okay. So when you have that chain selected, we're going to go ahead and click OK. And then we enter into lathe rough. We can use that same exact tool, which is T0101, 55 degree. And one thing that I do want to call out here as far as the note. So in order to delineate between on diameter and on the side, I call it, so whether you're calling out the full amount or just half of it, depending on what you're talking about on radius or on diameter. They use the letter U to basically denote that it's on diameter. That's what they use the U to stand for. So if I say U.020, that tells the operator that it's actually 10 thousandths per side because you're working on a round piece. Everybody with me so far? So if you're 20 thou over, when you go to finish, you're going to be taking 10 thousandths on the side. Okay. So either way, you can call it out however you want when you're, in your own work. They're all going to have their own standards. And then they also use W for the side wall. So U and W are what they use to call out the overages that we're going to leave on the roughing. So for a comment, we're going to rough POD. We're going to say that U equals 0.020 thousandths and W equals 0.003. So they're literally only leaving 3 thou on the wall.
How much is that?
3 thousandths, 0.003. So almost nothing at all. What I usually do, what I call out is 10, because it's just a nice, easier round number. 3 thousandths is basically nothing. There isn't really any tolerances on these parts either. It's not like super tight, so you don't really need to be that specific. I just want to make sure that if in your future travels, if you saw this, I want to make sure I expose it to you so you kind of would see this and not be like, what the hell is that? Because I would usually use D and Z personally. I say D 0.020, knowing that I'm talking about on diameter there. So inside of rough parameters next, we're just going to go through and decide what our depth of cuts are for the most part. Our entry amount and exit amount are fine because we're going to modify this in lead in, lead out for later. We're going to do equal depth of cuts. So equal steps is correct. And then we want to specify our depth of cut, okay? 100 thousandths is not a lot, depending on what kind of material you're using. In the G code they run during the day, we do 50 thousandths. So we're going to change that depth of cut to 0.050. And then our minimum depth of cut is going to be 0.01. So basically, it's going to calculate an equal number of steps, so 2, 4, 6, 8, whatever. And you don't really know what that number is going to be until it runs the math on it, right? So it's going to be somewhere in between 50 thousandths and 100 thousandths. Makes sense. Basically, you're kind of giving it an envelope to work in, because not everything's going to be divisible by 50 thou, right? So our stock to leave in the X is going to be the 0.01. All right, so this is that U figure. And again, you can check that by looking at where this graphic is showing us. So 10 thou on the side, 20 thousandths total U. Stock to leave in the Z is what that W letter references in the notes. And this would be our 0.003 thou. And again, if you look at the graphic, that only relates to that backside wall. So basically, like these areas here are going to be 3 thou oversize. Cutting method, one-way default is good. One thing on the bottom right-hand corner we want to make sure we do is we want to change the stock recognition because we want it to see our material up here. All right. If we don't turn this on, it's just going to come down here and do this. It's not going to cut the rest of the stock away. So inside of this drop down, we're going to change this to use stock for outer boundary. So it's going to look at that 1.5 inches that we have entered there, and that's where it's going to start its cuts. And that's how it's going to calculate what the equal steps need to be to get that down to where it needs to go. Okay. In plunge parameters, this is where we tell the tool to ignore all the areas that are underneath the straight cuts, meaning all the grooving. It's not all this here. It's not going to try to dive down. It's just going to go straight across. And basically the one on the left-hand side says no plunging whatsoever allowed. If you cycle to the right, you can see there's some that allows both, or just on the wall, or just on the floor. Okay, or floor and then wall, depending on what you want to do. Like for example, if we did want to dive in and just do this part of the groove here, well, we couldn't because then we tried diving here too. So just remember this is always here, plunge cut parameters, that's where to specify that. And now here's our lead in and lead out, and this is where we talk about extending the lead out of our contour anyway, so we have a nice flat area in the back to face off. So I ran into an issue last night where I didn't go far enough. So let me just double check and see what I did. I extended by 20 thou, which is not, that's definitely not enough. That's probably why I was screwed up. We don't really care what's happening to this piece behind here. So I'm just going to extend this by 100 thou, 0.100, and actually it depends on what the tool width is, right? So let's do 200 for now. We can come back and mess with it later. What I normally like to do is make sure I have at least the cutoff tool's width cleaned off back there. So you could look forward and say, okay, I'm going to use an 1/8 inch cutoff tool here. So maybe I'll use 0.13 or something like that. For now, we'll put a bigger number in there. We can always come back in and back it off later. So we're going to extend it by 200 thousandths. That should put us well out, somewhere out here where that stops. And then at this point, we are okay. So I'm going to click the OK box, and we'll let that run. Okay. So that looks good. We go all the way into the back. This last one here, this is what I was trying to eliminate. So there's like a little notch here. And the problem is this is going to come with us when we do the stock flip, but it's all right. We can mess with it later. So I'm going to just go ahead and run the back plot. It's pretty self-explanatory. I'll run the whole toolpath group. So I'll go back and highlight the facing and the roughing, and we'll let the whole thing run. And again, you can use the S key to skip past all the home movements. So this looks good. And again, 50 thou is not very aggressive. We could have done our 100, but I'm not too worried about it. It is interesting that last pass does not do that extra. It's weird that's kind of stopping there. Play around with that a little bit. Okay. So now that we've done that, we can also do the same thing with our facing, right? So basically the same exact tool path, except we're not going to rough from the 1.5. We're just going to take the 20 thou off diameter. We can use the same chain, which is nice, so we can do from last, like we've done in the previous sessions. And after that, we'll do the C-axis work. So I'm going to go up to General and go to Finish. Now, Oh, you know what? It's not gonna let me do last in here, is it, huh? All right, no big deal. We just got to repick that again. So it's the same exact chain. So I'm going to zoom in, click on the bottom of that chamfer, zoom back out and go to the back of the part. I'm going to do the same thing and make sure I get the bottom of that chamfer. So same exact chain, real easy. We're going to click OK. So now we're going to look for a finishing tool. And in our case, it's going to be T1919, 35-degree right-handed OD tool. And again, just to talk about the differences in inserts, you can kind of see when you highlight these things and get the bigger picture, you can see that the finishing tools are going to be called out by a lower included angle, so 35-degree, and that basically means it's a more aggressive tip, right? So it's not, you're not going to have as much surface contact with the part at the tip, but what you do is you ramp the RPMs and the feed rate up and you get a nice smooth surface finish using these tools. Versus the ones that have a wider tip, they hog more material at once. They have more surface area for cutting. So the comment in here, we don't really need anything special or fancy, right? We're just machining the size now, so we can just say finish the OD. Don't need to call anything out necessarily. One thing we could have done is, you know, we could have mentioned the fact that we were overcutting by 200 thou in the previous roughing note, so we could do the same thing here. Maybe we want to call out that we have, you know, I'll do brackets and say extended by 0.200, something like that. Again, that's going to be up to you what your shop wants and what you like to have in your programs when you're doing this stuff. I'm going to go to finish parameters next, and there's really nothing to talk about in here. No stock to leave. Number of finished passes is 1. We want to do it all at once, right? Plunge parameters, we want to check out and make sure that we do allow this to plunge now. So we basically are going to, oh no, I'm sorry, we don't. No, we do. This should be a separate, let me double check something here. Because I don't think I want to do that. Oh, you want to know what? I screwed us up because we should have changed our chain. I'm sorry. Let me click OK for a minute here. So we are going to want to plunge, but now you know what if we don't do this and we chain this the way we have it now, it's going to try and dump into the stack, right? So we should have stopped our chain a little bit earlier. I was wrong when we were talking about that. It's real easy to fix though. So if you're in plunge cut parameters, go ahead and say allow plunging, which is the second option. We're going to click OK. And I think if we go back into toolpath parameters, no, we can't get back into the chain here like you can in the mill. So let's click OK. You'll see why we don't want to do this, and then we'll change the chain, okay? So you see with that finishing tool now, if I run this, it actually does do what we want in the front here, but because we have it selected, it tries to dive down in here, and you can see that the angle doesn't allow it to actually get into these areas, so that's why we're not doing it. So the end of our chain, if you click OK and go back into your toolpath, open up number 3, go to geometry. We're going to repick this chain real quick. So in the chain manager, we're going to right click in the white space here and do, let's just do rechain all. And what we want to do is get the bottom of that front chamfer, as I stated before, but we're only going to finish up to this radius here, basically. All right, so I'm actually, let's finish this radius on this path. So I'm going to zoom in and get the bottom of the radius on the back here, and that's going to be the end. So basically our tool is going to come up, it'll clean out this area here, it'll come down and slow down to this radius, and then that's going to be the end of our cut. because we're going to do the other stuff on the back when we flip it over. So when I click OK on this, and OK again, we're going to update that toolpath. And then we're going to check that out and make sure. So it should look something like this. There it goes. I'm not even sure if I want to do the radius here, but we can talk about that because that's kind of a funky move. If we do the radius on the back half of this when we flip, it won't have that weird cut into the stock. So actually, maybe we do want to exclude that radius and just go to the end of that line. You know what I mean? If you think about it, so there's still stock there. So this thing's going to do a kind of a funky dive into the stock and then pull back out. If we just go to the straight line and come straight back up, that'll all be gone when we flip it and we can finish the radius on the second half. So I'm going to modify that one more time. Sorry about that. Chain, rechain all. Bottom of that chamfer, and then just the end of that straight line there. It's good practice anyways. So go ahead and go back into that rechaining dialog box. And you should have the chain that looks like this after you're done. In there. Yeah, we'll mess around with that. Okay, because you got to flip yours over. Yeah, we'll do it all again at the end. It won't take long. Okay.
I'm just following your steps there.
Okay. Yeah. Thank you. We can flip it all.
Yeah, and then skip the whole thing.
Yeah.
That's the late finish, right?
Yeah, this was the finish. Correct. Yeah.
Okay, I got it.
So, you know, just thinking out loud here. So I might even go a little bit past the radius just to make sure, because I don't want to leave this here. You see the tool nose. So I'm thinking we could even go a little bit farther past this, you know, just to make sure we clean that radius really well on the back end. So we'll go back into parameters, finish parameters, lead in and lead out. We're not worried about the lead in. So we'll go to the lead out tab. And why don't we just extend that last move by 50 thou or something like that and see if we can get by the tool nose there. The tool nose shouldn't be bigger than 50. We'll double check. So I'm extending the lead out of the lathe finish by 50 thousandths. Click OK, and we'll click OK there. And basically what I want to see is just, I want to see that our tool nose clears the back of that radius, which it does. I saw the quick little preview. Perfect. So I'll give us a nice spot to clean that up with later. Now you will notice that the stock looks kind of weird on mine, probably on yours too. But if you run the back plot, you'll notice that, the tool nose, when you slow it down, it's touching the part. Okay, so what that's showing you, it's not showing you the finished size of the OD, that gray area. I don't know if it's showing you the center line of the tool nose there, or it could just be, I don't know why it's doing that, to be honest with you. Normally it lines up better than that. One thing I want to make a note of, so when you're in lathe especially, if you right click and just do top to get your view back in place, you see what happened to my plane? I do this all the time, so that's why I remember this. So my CNT kicked up to the top plane, which can be an issue because you could do some work now. Your next one could be on that top plane. It's not going to look wrong to you because it's in alignment with the D plus Z plus, but because it's not the right one, it's going to throw an error, right? It's going to say not in the construction plane or something like that. And it's going to drive you nuts because it's going to look right, but it's not. So just make sure if you do a tendency to do this and pick these to kind of look at different areas, just make sure that you go back into your planes and reset this before you do any more tool paths. Okay. So we are good with this stuff. I'm going to save this. And now we're going to do a really simple, oh, I'm sorry, we need a thread first. We'll do the thread first because I want to do the C-axis last. So the threading is where I got screwed up, Matt, because we have a different insert profile than the default does at home. So when you go to pick your tool, you're going to have to shorten up the length a little bit
Okay.
in order to not crash against the back of it. And you'll see what I mean in a second when you go to do it.
All right.
It's really easy, though. It's not a big deal. I should just send you a tool, but I didn't think about it. So in order for us to do the threading, real simple, we're going to go through the drop down. We're going to expand the gallery inside of the general. And then it's on the right-hand side on the second row. It's called thread. So we have a 60-degree OD right-hand thread insert. If you were working at home right now, the only threaded insert that we have is kind of at an angle. And what that means is if you try to go the full length that this tutorial calls out, that thread profile doesn't actually work. It hits the back of the sidewall. It's not flush straight like this. And this is actually a custom shape. So I tried building it from home, and I had a little bit of an issue yesterday. So I should probably just copy this tool tool library and send it to you so you have it. I'll probably do that today before I leave. So if you remember the print, we're looking for a 1/4-20 thread, okay? And it's typical on both sides, and it's 3/8 long, okay? So if we are operating from Z0 here, it makes it easy because we just want to end up somewhere in the back of this relief here, but not far enough that we hit the back wall. So I think we do 3.35, which basically gets us to like the center of the relief. And that's a good mark to hit. You know, if you're in the center of the relief, that's usually pretty good. You want to make sure that the real important thing is that you make sure you get a full thread in the back of this chamfer here. Because if you want whatever's going on to go all the way up the shoulder, you want to make sure you got a full thread here and it doesn't stop and get hung up. So in the comment, we're just going to say wave turn 1/4-20 thread. We're going to go to thread shape parameters. And it's really easy to do this. So we're going to just go to the table. It's a standard thread. So we're going to select from table under thread form. And we're going to change the thread form to, I think it's under unified. No, let me double check. Give me 1 second. 1/4-20. There you go. 1/4-20 UNC. So the drop down here, we're going to change this to unified, UN, UNC, UNF, etc. And then on the right-hand side, you can read the comments. You can see what size threads are in here. So there are a bunch of different options. Like there's Acme threads, there's some buttress threads, there's metric threads in here, there's NPTs. As you change these drop downs, you'll get different options. Most of the stuff that we're going to be using is all in this unified UNC. So we're going to scroll down and look at the comments until we see a 1/4-20. You'll see that the basic major is a 1/4 inch. The lead is 20, that's the TPI, and then it has the major and minor diameters. We're going to go ahead and click on that, and it inserts all of those values in for us.
Which one are you select?
1/4-20.
Contours of the UNC?
Yeah.
Okay, thank you.
You're welcome. You know, there was a point in time where you had to go into your machinery's handbook or whatever and pull this data out, or you could do the math, right? Because you can get the pitch and the depth of these threads based on how many TPIs there are. So there's formulas for you take the 20, you divide it by you take 1 divided by 20 to get the pitch. And then there's a certain value, I forget what the number is, but then you can multiply the pitch by a certain number, and that gets you the depth per side of the thread. There's like a ratio to that. From right now, all this does, this just goes in the table, we pull it in here and we're done. So it's pretty sweet. There are some allowances that I actually have not dealt with before. And there were some allowances in here. Let me look in here for a second. Okay, so this is actually the same thing. So there are major and minor tolerances depending on what size thread there are. And you don't need to hand type these in either. It looks like we can actually go into the select from table for the allowances and grab that same 1/4-20. And that's actually what I remember seeing. So it's 11/10. Basically 11/10 either way on the minor or the major. So when you click on that, I think that just drops in the 11/10 in the major and minor. You got 0.0011 and 0.0011.
1/4-20 UNC, right?
Yes, yeah. You're basically matching the allowances there. Now, I don't know what that does. I mean, I don't know how that affects the machine code or anything like that. I don't know. Maybe we can check the post and see where that allowance is. It might have something to do with like the number of cuts. It may make it so that it stays within that range. It's a really small number though, so. I do want to check and make sure that all this number looks correct, right? So my major is 1/4, my minor is 0.195. My thread depth is calculated based on these numbers here. There's my thread angle, that's fine. Included angle is 60, that's good. My lead is 20 threads per inch. Now the start and end position, that is where we got to make sure that we position the length so that we end up in the middle of that release. So our start position, if you look at the graph, is going to be 0 because that's where our WCS is, so that's great. Our end position, we can either hand type this in or we can click a surface, right? Or we can click an area. So I'll just show you. We can click on end position. If I click on this side face here or on this line here, there's our negative 3.75, right, from the print. And then we want to back up from that. I don't know if it's going to let me grab a center point on this surface. Not really. You kind of grab this here, but again, that means you're not really going to get a full thread because you're not going to get out past the relief. So you kind of got to go somewhere in between, right? So in this case, we're doing negative 0.35. And that's basically going to get us right in the middle there. Except for poor Matt, because Matt's going to crash if he uses that number. So,
0.325?
yeah, negative 0.35. So negative 0.35 gets us, and I'll slow this way down to, here we go. So that gets us basically to the start of that back chamfer. And again, that negative 0.35 only works because this tool is in here straight. So Matt, if you see what I'm talking about and you're hitting the back, back the end of that thread out to like negative 2.9, I think. And that'll give you enough clearance. And then just leave it like that.
Okay, I started with negative 250, but yeah, I'll do that.
That's fine. You know what I mean though? Because
Yeah, I see.
You must have, okay. You wouldn't have the issue if you had this tool.
Right.
So you see the number of cuts here. And again, it's not going to show you a thread. You're just going to see the tool kind of pass through the solid. When you go to solid verify it, it does show you a thread, which I guess is kind of nice, but in the back plot, you're not going to see it. You can kind of take this for granted that it's just getting down to the right depth and we're not really worried about anything else right now. Okay. So that's the threading. I am going to save this. I am going to turn my toolpath off by selecting the toolpath group number 1 and hitting the toggle display. I'm going to turn those all off so they're not in our way. It's the, so you're good. So you've actually, it doesn't look like it's showing a bunch of stuff, so you can actually see what we're doing. Now this part, you're probably not going to be able to do until we flip it over.
Okay.
And I'm recording too, though, so you'll have this too later. All right, so I saved this, and now we're going to perform our C-axis contour, okay? It's really, really simple. It's just you've got a few little things you've got to work around in order to get this to form the right profile that we want. So we are going to go up and look at our C-axis options. So you'll see that we have a C-axis contour, a face contour, frost contour, face drilling, and then some cross drilling. So the C-axis contour stuff is if you're like doing a pocket on a side face. So like let's say we had a pocket here and we wanted our tool to come from the side. So if your part is like this, your end mill would be this. Okay, that's a C-axis contour. If we do a face contour, your tool is going to be in line with the axis still. It's just going to be off the center line, meaning we're going to be able to mill like a hex. We do a lot of milling hexes and stuff like that. Your tool is still in line with that axis. It's not 90 degrees to it. So it's actually a really simple process to do. So we're going to go to face contour. And we're going to select our geometry. So we do need to think about this from the tool's perspective, okay? You can't use the solid face because coming in from the side here, it's only going to look like a point. You know what I mean? So if you're looking at it like this, and you're looking at it for a depth and something like this, everything's in line. So if you try to pick the face, it gets confused. It doesn't really know what you want. What we want is we basically want the outer edge of these two faces, and then we're going to specify a depth from 0 going this direction, kind of like the thread, using that Z minus value. We're going to take both these cuts at once. So what I want to do is start on one end from the bottom, go up, and then come back around, and then drop down. So it's basically a cut like a U shape. So I'm going to start by rotating the part. I'm not going to use the right click and right because it'll change your WCS. You still want to be on DZ. I'm just going to rotate with my mouse around so I can kind of see both. And then I'm going to basically select the flat part of the chain that I can get. The radius here, the fillet, is going to screw us up a little bit. We're going to have to manually fix that. All we want to do is get this line right in front. And I want to go from the bottom first. So I'm going to go right here and grab that. Other face. Actually, I screwed up. I shouldn't have had face selected. So I'm going to delete, I'm going to clear that. You see how it says face and loop? I don't want face or loop. I only want edges. I want to pick two individual edges. So if on your screen, facing and loop are selected, turn those off and make sure facing is on. I only want to get one line per click, basically. So now I'm going to come over and click that one on the right closer to the bottom. I'm going to get a green arrow going up with a red and blue at the end. That's good. Now I'm going to come around the other way, and I'm going to basically click the back half line in the same spot. I want to click towards the bottom here. And then what I'm going to do is, what did I do last time? Let's see if it does it the way I want to. If not, I may have screwed up. I may want to click the top line and then go in the other direction. But we'll find out when it runs. So you should have both those lines selected. I'm going to click OK. And now you're going to see we're in a C-axis toolpath. C-axis face contour. Okay. So we're going to walk through this. We'll leave the chain alone. We'll see if we like it at the end. I'm going to show you what happens if we don't modify the start and ends, and then you'll see why we have to, and then we'll extend some stuff and make it look the way it's supposed to. Basically, this fillet is screwing our chain up. We have to manually adjust for that. So with our tool, we just want to use something that is realistic. I used a 1/2 inch for what I was doing, the same thing here. You want it to be a large enough tool so that it's stiff, it's not going to deflect. And there's nothing really constraining you as to what size. Just remember you're using the side face. All right, so you're not using the bottom of this end mill. You're going to mill with the side face. So if you use a really skinny one, it's going to deflect. So you want to keep that in mind. You want to stick your rugged tool if you're side milling like that. So we're going to go into Select Library Tool, and it dumps me into my SD20 tool library because we're using the SD20, and I don't know if it doesn't look like it has any tools in it, which is not ideal. So let's go into the new library, and we'll go and select a different tool and library to get an end mill out of. So again, I'm going to go into Select Library Tool. We're going to go up to New Library, and let's just go into the ST10 because I think the STCC ST10 has stuff in it. No? All right. It's looking for milling tools, so that's why it's not showing anything. I know we can just go into live tooling. Yeah, let's just go into the STCC live tooling. Matt, for you may have to go into lathe inch and see if they have end mills in that. I'm pretty sure they do. Or there's also like L mills. I know that's a default in Mastercam. L mills will probably have it in there too.
Yeah, I just checked the library. I do have M mills.
Okay, perfect. That's fine. I'm going to go into the stick live tooling and see what's in there. Yeah, there's 215 in the stick live tooling. So that's good. So STCC live tooling, and then for us, I'm just looking for a 1/2 inch, like I mentioned. So I'm going to sort by diameter in here and just kind of scroll through. And it looks like there's a couple different options. I'm looking for a rougher. There's 3 finishes, and then it looks like tool number 100 looks pretty good. It's a longer one, 4.7 inches, but it's still a finishing end mill. I really kind of wanted a 4-fluter, but this is fine. So let's do tool number 100 in the STCC live tooling library. And again, I filter by diameter. That's usually how I like to look at things. So it should be 0.5. So I'm going to grab that. And then in our comments here, I'm going to go ahead and say mill the flats, or mill C-axis flats, something like that. Normally we call out our depth here. We haven't confirmed it yet, so we could call it, we could do a Z minus X dot XX and just come in and fill it later. It's not a very deep feature, but we'll come back and add the value in here afterwards. Is everyone okay with that milling cutter? Does everybody have that 1/2 inch cutter? Sounds like it.
I think that's a drill.
Oh, is it a drill? See, I'm glad you mentioned it now. Tool number 100. Oh, you're right. Drill high speed. Look at that. Thank you. That would have been embarrassing. So, all right. So what do we got? 1/2 inch finish end mill. That's 2 inches long. Let's just take that. So that's tool number 21. Thank you. That explained all the blank stares I was getting. That's what I get for not extending my filter out. Yeah, so tool number 21, 1/2 inch finish end mill. That's fine. The goal was to do this all in one cut, so that's why I wanted a roughing end mill, but it's not a big deal. Thank you. So tool number 21. So if note still applies, that all looks good. Now I got a freaking drill in here, but that's fine. We'll ignore that. Good. So holder will bypass. You'll notice that everything else from here on out is going to look exactly the same for the most part. So cut parameters, we'll switch it to where so we can do tool offsetting. That's one thing I haven't really been discussing too much, but we do want to make sure we have the right comp type. Generally speaking, the operator is going to want to type in some kind of wear compensation himself and not let the computer do it for him, especially because, you know, tools wear out over time. So the ML might be 0.499, you know, they want to be able to add those offsets in by themselves. And then, like I mentioned, we're not going to leave anything on the walls or floors. We're just going to do it all in one pass. Rip through it real quick. It's not really, I think this feature is only here for weight removal. It's one of those deals for the R2. It's not really a feature that actually has any mechanical purpose. So our depth of cut, again, we got to think in relation to what the tool is doing. So if we're the tool and we're looking at it from the side, our depth of cut is actually going in the axial direction, right? So if we wanted to, if this was too long of a flat to do all at once, we would do depth cuts here. But in this case, we're fine. We're going to skip by lead in for now. We're going to skip through breakthrough and all that stuff for now. We're going to go right to linking parameters. Okay. So same numbers, but again, we got to think about it as coming in from the side of the part. So we're all going to do all absolute like we normally do. So I'm going to switch all these to absolute first. Now our clearance of 1/4 of an inch is probably fine because it's from this edge over here. I don't actually think we changed much of this stuff, really. The retract and the feed plane we can leave alone. The top of stock and the depth is where it's going to get a little fun. And actually, the numbers that I have over here from yesterday don't even make sense to me right now, to be honest with you. Oh, because I had incremental there. That's why. That was why. Okay. So our top of stock is actually going to be this side face here. And that's because that's where our stock starts, right? That round area. So we can go ahead and click on top of stock. We can grab that same line that we used for the geometry. And you're going to see that that's negative 0.375. And that lines up with the print value because coming from 0 and going back to that surface, that's 0.375. Now for our depth, you can kind of infer what we're going to do next, right? We're going to click on depth and we're going to go to the back of that slot. And that's going to be the depth of our end mill. So we're going to click on depth. I'm going to swing around to get the back of the slot here. And that comes out to negative 0.5. Okay. Now that's our bare minimum depth value. So we don't want to end our end mill there because we'll end up with a sharp edge and a rolled over piece of material there. So we want to go past a little bit farther. And again, you can either do that by adding depth, or in this case, I think the breakthrough is going to work in the same way. So if I put a breakthrough here, it's going to break through that direction. If it doesn't, we'll know right away and we'll just add it to the linking parameters, but I think it will. So let's break through. There's nothing to really worry about in the back, although there is still some stock there, so we don't want to like barrel through it. But let's just break through like maybe 25 thousandths, 0.025, something like that. You got to remember that we're basically going to be cutting, the bottom of the end mill is going to be cutting as well as the side face at that point. So we don't want to really bury it back there for no reason. You know, we can turn coolant on, turn the flood on, might as well. We haven't talked about that at all with lathe, but we'd be turning the coolant on pretty much every time and leaving it on. So now we can click OK. and we can kind of review what this is doing. We can talk about why we need to change a couple of things, and then we can make the adjustments. So we're going to click OK. I'm going to look at it from the side face, and yeah, we got an issue here already. A different issue than I was expecting, but that's all right. So now I'm going to run the back plot and slow it down. And the first thing I want to look at is where this end mill kind of starts. Based off of front better. I want to get a good view here. All right. Too slow? Yeah. Here we go. So you'll see that it's basically starting, the center line of the end mill is starting where that line is where we picked it. Okay. Not great, because what this is basically doing is plunging into that area, and that's going to go to the right. So you're going to have a little a dimple there where it starts. We want to start off set of the part by a little bit. Now, the reason why we have an issue with that is because this flat stops here, and then we get that fillet, and there's not a good way to chain that. At least not an easy way to chain that without having to, we could have drawn like lines and extended the lines out. But we can also do lead in and lead out and just extend them out that way without having to draw geometry. So that's the way that I chose to show you. We'll fix that up later. And then we do have an issue with that second chain that we need to address too. But let's let this run. So we're going to come all the way down to the bottom, right? So there's that, and our extra 20 thou. So we're coming straight up. That's great. Now, I think our issue is that we end up on the wrong side of the line on the second chain. So now we're pulling back. So instead of doing like a loop around like I wanted to, we're going back. And our compensation is such that it's cutting the inside of that second line. So that's the adjustment that we have to make there. So I think we could just flip that second line over and we'll be good there. But I also want to get it so that it comes around smoothly, doesn't back out that way. So let me kind of make the adjustments at first and talk about it, and then I'll have you follow me. So I'm going to go and review my geometry chain first. And so this is where the issue is. You see the smaller arrows that the smaller arrows that denote the cut direction are correct on the right and wrong on the left. So we have to switch the left ones. Because of the way I picked the chain, it's not going to allow me to flip just one. So if I right click and do change side, you're always going to have one. So we have to isolate those two chains. So I'm just going to end up deleting this and rechaining the whole thing. And I think I'm going to go with the same pick. Oops. So I want this line, but then I'm going to end that chain, which is what I didn't do last time. So we ended that, it isolates it. And now I'm going to click this up on top. So that's where I want my start position to be for the second one. My green arrow should be going down on the second, and now the tool is going to do that U shape now instead. So I missed that isolating step. We had to separate those out. So when I click OK now, oh, it still didn't do it though. Well, I can actually, if I open up solid chain 2 and just select this one, can I just change that one? There we go. So now all my small cutting arrows are outside of the geometry that we want to cut. And hypothetically speaking, I may also need to keep tool down at depth or whatever to get it to do my full U without doing anything else. So let's double check. So I'll click OK and regenerate. And again, I'll come back and we'll talk about this. Let me just make sure it does what I want to do. That looks good. So it should come, oh, it's still gonna come out. Yeah, so I think we need to keep the tool at depth in order for it to go up and around. And now it's gonna plunge in the top. And again, we'll adjust the start of the contour to change that. And then it'll come down. So that tells me that our chain is good. I'm happy with that. So let's go back in and we'll adjust the chain on all your individual files. So what you're going to want to do is go to the toolpath number 5 and go into geometry. That's going to get you in your chain manager. You can either right click and delete, or you can just right click and do rechain all. And then again, we want to have 2 separate picks. So I make sure that our selection method is edges. I'm going to click the bottom of my right hand flat here. I'm going to hit the blue end chain button under selection. And then I'm going to click on the top part of that chain on the left-hand side. That direction looks good. And then I'll click OK. So in this case, when I repicked it, you know, the outside chains are good, the cut direction's good. But if you want to flip those, you can open the minus button and select the individual edges to flip. Now, my other comment about keep the tool down, there should be somewhere in here that I believe in here that allows you to do that. Only if we have multi-passes, though. I'm not as concerned about that right now, so we'll skip by that, and let's just talk about extending the cuts. So for milling, just like in lathe, the lead in and lead out is what contains the end and the start and exit adjustments if you want to extend the contours. Right now they're turned off and they're at the very bottom of this screen here and lead in and lead out. So adjust start of contour, adjust end of contour. So we'll turn the lead in and lead out on. I'm not going to change the entry or exit lead ins here and lead out up top. I'm going to leave those as default. I am going to come down to the adjust contours. I'm going to turn both of those on. So I'm going to adjust the start of the contour and I'm going to adjust the end of the contour. So we're going to make both of those active. We're going to be extending them, not shortening them. So I'm going to click on the extend radial buttons. And then we need to decide how much length we need. Okay, it's not much. If we want to be specific, we could look at the size of that fillet. So the radius on that fillet is 20 thou. So that's the minimum that we want to extend. We probably want to go a little bit farther than that so that we come in way off, not way off the part, but we ensure that we're not nicking anything. So I'm going to go ahead and change, let's say 30, let's go 50 thou to start. One thing you want to pay attention to, the first box is percentage and the second box is actually a linear dimension. It's not super clear when you first look at this. So if you type 0.05 in the first box, that's 0.05% of the tool width, which means it's actually 0.000025, right? So if you want to specify a real length, you've got to type it in the second box on the right, 0.050. And then that calculates the percentage based on your tool width. I'm going to do the same thing on adjust end, or you can just click on the arrow in between that throws your start value over to your end value. Okay. So once we do this and we backplot that same tool path, hypothetically speaking, the end mill should be starting off of the part. So if I look at it from the right-hand side and we let this run, I'm looking at the apex of the quadrant of the end mill, and I want to see what the tallest point is starting off the part, which it did. And it also clears off the part all the way too. So we're still getting that pull-out move, which is fine. It's going to go up. So it's not doing exactly what I want it to do, but it's not doing anything wrong necessarily. So again, here's the clearance we have here. So there's plenty. We're wasting a little bit of time on that lead in there, but I mean, it's not that big of a deal. And we got a nice clean cut there. Okay. So there's your first live tooling experience. Well, I don't know if it's your first, but that's the first instance of live tooling here. You just got to be careful about your planes when you're first doing this. Again, you know, you probably want to check every time you do something like I just did and make sure you're looking at the right stuff. And as I said, there is a better way to do this. I know I did it. Let me just double check my other file over here. I did it all in one pass. I mean, not one pass, but one, oh, come on. It's mad at me because I have two master cams open. There we go. So I have the chains lit up on mine. Let me just double check something. So even just maybe instead of just not doing that end, because this still says one chain, even though I have two segments selected. So let me just double try this. I'll retry this real quick. Rechain all. Maybe I'm just going to go that one, click OK, add a chain, that one, click OK. Now I have two chain segments. That did it. Okay. No, it still didn't do it. Might want to do it. Yeah, it's all right. I'm not worried about it. It shows it here, which is interesting. You see that?
Yeah, because your position, you see how you position when you go to the other?
Yeah, yep.
Yeah, that's why you get the curve, because your side here is opposite. What you have here in your other computer, the location.
Yeah. Yeah, so it's actually, well, no, this is actually, I have that. Well, we flipped that too. You see that?
Yeah.
I said, oh yeah, it's exactly the same.
Yeah, that's what I'm saying.
Yeah, you're right. Yeah. Yeah.
It's not.
So it wasn't doing it
for you.
Yeah, it wasn't doing that. It wasn't doing that before. Yeah. Anyways, I just thought it was. Okay. Cool. So we'll save this. What time we got? Oh.
7:05.
Okay. So we'll do the cutoff, and then I'm gonna have you. We'll do the cutoff and the flip, and then I'm gonna have you do the machining stuff on the back by yourselves for the rest of the class. I want to do the stock flip as a group because we don't do that very often. And I'm getting better grip. I'm getting better grasp of it too, because I don't do it as often either.
It's the flip.
Yeah, the stock flip. No, we'll have to actually we'll actually have to flip yours physically in the system, but we'll do it. It's not a big deal. It won't take long. So I'm going to hide my tool paths again, and then we're just going to perform our part off. Okay. So we're going to go up to general again and expand the gallery, and we're going to go and look for cutoffs. So we're going to use the stock as our boundary point. So it doesn't really matter where we click as long as you get the back of the part. We're really only specifying our Z position, not so much our D when we select. So I'm just going to go ahead and click on the back of the part, the bottom of that chamfer. I try to get the point to the tallest point, so the tallest quadrant point like that. And I'm going to go looking for a straight tool We're gonna try to go back in, we're gonna have to exit the live tooling, because obviously it's not a live tool.
Where did you press off?
We gotta go into select library tool.
Yeah.
And we gotta go looking in a new library. So I'm gonna switch back to the ST10 or the ST20, either one of those should work. Again, it doesn't matter where the tool is living as far as the program goes, as long as you change the tool numbers and stuff like that at the machine when you're loading in the real thing. So inside of the ST10, it looks like there's 3 cutoff tools, 2 .118 and a .125. And what we're really looking at here is the diameter max. So that basically is dictated by the amount that the tool is sticking out. So 1.5 is going to be okay for us because at this point, well, let me just double check. Yeah, 1.5 is plenty because out at its largest point right now, we're looking at 1/2 inch. So there's plenty of room back there. So anything you can grab that's similar, Matt. You just want to make sure it's a right hand. So you want the actual tool holder to be towards the right. You don't want to be going towards the chuck.
Right, no problem.
And our comment is going to be part off. At, you know, we could say Z minus whatever the total length is. So the total length of this part is 1.38. So why don't we call Z minus 1.38 out just for the hell of it. If you want to save some material on the back for facing later on, which I don't, you can do that in cutoff parameters in the back here. We're just gonna do a straight cut though. When you're parting off, you get a pretty good surface. I don't think you need to rough, unless you're really worried about perpendicularity in the back, because that tool might shift a little bit. It tends to be a thinner profile tool. Now, inside of cutoff parameters, as I mentioned, we're gonna go from stock. So we're just gonna click on that box from stock. And that means the entry amount is gonna start 100 thousandths below whatever remaining stock we have left. So it's gonna add those 2 numbers up. Again, let me just double check and make sure I'm not missing anything in my other file from yesterday. So the retract radius will also be from stock. Then, as I mentioned, we're not going to leave any stock on the back face. And there is no X tangent point because there is no hole through, right? So we're going to go all the way down to our axis, which is at 0. Okay. I'm just going to check our lead in and lead out. I don't think there's anything in there we got to do. There's nothing turned on. Just double checking. And from that, we are good. So I can click OK. We are going to want to check. I take that back. We didn't check the stock thing. So we bumped into this last time. Let me go back into parameters for a second. On this first page in toolpath parameters, there's a stock update box. And that's important because we want to make sure we have the right selection so that when we do the stock flip, we're keeping the piece that we want to actually keep. So inside of stock update, we should have it selected that we want to keep the separated piece only. So when we go into stock update, you'll notice that we have keep piece in active chuck selected, which basically means it's only going to recognize the stock that's left in the chuck to the left of the part. We want the exact opposite. We just want the part that we cut off because we're going to flip it over and finish it. So we're going to change that to keep separated piece. And now we're going to click OK and regenerate that. Okay. So now you'll see when we complete that operation and the red insert flag is at the bottom, you'll see that the only piece of stock remaining on the screen now is what's left of the back half that we didn't cut into. So that's perfect. We're going to save that. And now we are ready for Op 20. I did not rename my first toolpath group, so I'm going to go ahead and just double click on that and rename this to Op 10. And we'll hide my toolpath again. And then the first operation that we have in Op 20 is going to be the stock flip. So we're going to add a new toolpath group. And we do that by right-clicking on machine group number 1, going to groups, and then selecting new toolpath group. And we're going to immediately rename that to Op 20. Now, we don't have any level work to do, because if you remember from the prior time we did this, when we actually flip the part, it creates a new solid model for us. It copies it, flips it itself, and it also will create a level for us when it does that. So we can come back and rename it later, but we don't need to manually do anything with the solid. We're going to let MasterCam do it all itself. And I'm going to be able to explain this a lot better than I did the last time, hopefully. So this is actually going to be a toolpath op for us, even though it's not, all it's going to happen is the truck is going to open, the gentleman's going to put the part in, it's going to close. It's not really a toolpath per se, but it comes in here as a toolpath. So inside of lathe turning, we're going to go to part handling and do stock flip. And now we're going to walk through this geometry and kind of talk about what these parameters mean. And then hopefully at the end, we should be in good shape here. So active spindle is still left. Our transfer geometry is going to be the part. All right, so that's the solid part. So we click on select. We highlight the part. We click end selection. Now, we don't want to blank the original. So we want to keep the original there and put a new one on a new level. So we're going to uncheck blank geometry. Under level options, we're going to copy that geometry to a new level, and we're going to give that a number. So we don't want to use 1 because we're already using it. So let's go ahead and just do 100. Just to get it, just make sure we're definitely not creating one that's already there or trying to. Now, our stock position and our transferred position. So this is where I got a little weird, but these numbers make more sense to me now. So the original position, we leave at 0. Don't worry about that. The transferred position for this file is -0.375. So just type that in for a second, and then we'll talk. So -375 is the shoulder, is basically the shoulder of this guy here, right? We know that value because we've been working with it, okay? When this thing flips, it's basically saying that we're going to be holding on by the shoulder, basically. I don't think we're going to check it out and see what it looks like, but it's basically going to rotate this around, and it's all going to be based right here. And it works out when I do it. So we'll check the flip, and then we'll look at it and see if that number, how that number works. The original position and the final position are 1.5 and -4, and those numbers are coming from the stock values that we put in there originally, right? So that -4, remember we put that in the, what was it, the chuck setup, right? And then the diameter of the original stock piece. So we're going to leave those alone, and I'm going to click OK. You guys don't click OK yet. I just want to do mine first so we can see what happens. So I'm going to click OK, and basically, it didn't do exactly what I thought it was going to do. Let me just double check. So if I have overlap on mine, yeah, no, that's basically it. So the end of the part here, you see the end of the part is at that 0.375 position. So basically it's offsetting from there back to that area. And the WCS, you see what the WCS is now for that GV is here. So this is kind of like your 0 point, what I was talking about. So this is kind of like the inflection point, or the touch-off point. And this is where your chuck is. And I think what they're doing is they're actually screwing this into a fixture and bottoming out on this. So when they bottom out here, they know this is 0. And that's why you have that 375 offset from the original. So in the original here, you go negative 375, which kicks us out and pushes you back into where that original WCS is. And I know I'm pointing a lot, Nat, so that doesn't really help you that much. But if you highlight the parts, you kind of see where the overlap is on the screen here. You see where our D plus Z plus ends up.
Yep.
Ends up on this. So basically, what they're doing is they're screwing this thing into a fixture, bottoming out on this base, and that's the 0. So that's why that negative 375 number works for what we're doing. Okay. Now, what we can do is we're going to go ahead and go to levels, and we can turn off number 1. We're not worried about it anymore. We're looking at the part handling transform geometry, which is a mouthful. We'll rename that to Op20. Op20 car front axle. And we're going to leave that D plus Z plus plane there. That's still going to be our active WCS. Now, this is where the numbers get a little weird, right? Because now everything that we're cutting on the right-hand side is actually going to be a positive number versus a negative number. And that's why I don't really like the way this is set up. I'd much prefer to have this be 0. And then this is where that value comes in when we're hand typing in the threading dimensions. It's going to be negative. It's going to be positive 600 something because we're going from this point out to here instead of from the front face and back. So it just makes it a little bit awkward when you're hand typing stuff in. The machine doesn't care because it's going to just calculate whatever it calculates based on that, and it'll post whatever values you want. But when you hand type stuff in, you got to be cognizant of where your Z0 is, or where your Z0 is. So I'm going to go ahead and save that. You'll notice that we have another DZ created, but it is exactly the same. Is it exactly the same? No, I think that, so that the one in brackets, I think actually came in from when we were doing the milling. So make sure that you're performing all your work on that plus D plus Z, the original WCS. Okay. And I'll come do a stock flip with you. We just did it real quick. I'll show you how to do it. But yeah, so at this point, you are ready to do the final machining, and I'm going to let the rest of the class perform those operations by yourselves again. And you're basically going to follow the same steps, right? We don't need the facing, but you're going to do a lathe rough, a lathe finish, and a lathe thread.
So lathe rough?
Yeah. Lathe finish and a lathe thread. And they're exactly the same as what we just did in Op10, basically. I don't know if you can copy them down into there, but you can try it. You're not going to gain much by copy pasting because you still need to rechain everything. You know what I mean? So just use the same parameters. So the roughing is going to be 20,000 to 003 W, right? Finish will be 0, 0, and then the thread to quarter 20 again. And the only thing that you're going to have to do is I'm going to let you try to figure out where your endpoint should be for that thread, right? I already gave you a hint. It's positive 600 something, but take a look at it and see if you can figure it out. And then once you're completed with that, you can have me look at it if you want, and you can save it and submit it. And then if you got other work to do, you can continue on, or otherwise you're done for the night. Your preference.
Right.
Okay? Does anybody have any questions or want to go over anything else that we just talked about?
Yeah.
You good? Yes. Yeah, if you don't mind, I'll do his stock flip first, and then I'll come over, because yours is going to be a little more expensive, so we'll flip it.
Got it.
Okay. Awesome.
So you got all the way through to the
So, the next step in this process is to get parts and power off. So you can go to general, and you can expand the gallery so you can see the bottom. Yeah, just search. And then move for file. So we're going to select the action part, and we're going to remove that thing. I try to get the top quadrant. Yeah. So we're going to go into the library and find a tool. And we're not saving, we're still in live tool. So we need to change the library back to the.
Will.
For the.
Will, tell me. Will.
And now we use the D1111. And the reason being is because it has a 1.5 inch diameter length, which is about the way it's going to happen. And for a comment, we just said, party off. And then we called out.
Okay, turn on your phone.
So if you have the.
Charge your mobile. Or something.
D minus one.
Okay, let me see.
So basically it's the same with that one. And then in parameters, we're going to go from stock. So basically it's going to look at what's left and then start on down below. And then that retread rate is also in stock. If you're looking at global track radius, on the right hand side. And there isn't very much more to look at. In here, we're not, there's no holes through, so there's no end. And we're not leaving any time. So what we do is change, so what piece we're going to keep working on. So if you go back to that parameter, and then update. Right now, it's going to keep the piece in the truck. And that's the opposite of what we actually put on for separated piece. So you're going to click on piece separate. So basically, you do it. Now, when you click OK and OK again, what you're going to see happen is that part here. So you have that same sliver. That issue, I had that same issue before, which is why I added the extension. And it looks like you may have missed those. So that means, yeah, when you click OK again, you see that line going up like that thing. So let's go into your leg block. So let's put it in the out. See that? So you extend the front. So I think we did 200. And then get rid of the lead in. Yeah. And then do the same thing for your finish. That's how I got rid of that last night, because I had the same thing. I think you're going to. You have it there. So when you regenerate all that, that little. There you go, see that? So that's why I did that. So now we're gonna do the stock flip, and that's gonna be done on a rubber, tool pass loop. So if you break with that machine. So you don't wanna do it there, you actually want to do a couple of them. So you want to do tool pass. So we're keeping it in the same machine. So that means we're in the same thing. So this will be your ops 20, and you want to rename that right away, and then we'll rename the first one. So now we're ready to do the stock, and that command for department was right. Stock. You're in the right tab. You gotta find the right one. So for this, your geometry is going to be the part. So you can put on full left. You're going to highlight the column that we're basically with. Yeah, it'll select the whole thing. Yeah, right. So we don't want to get rid of the original geometry. We want to keep it. You want to uncheck that blank geometry. Basically, you don't want to get rid of it. You want to keep the original one. And to the right of that, we also want to put this on different levels. So you want to copy where copy the flip part of the level, and then you can name what level you want. Like we did 100. Right now, it's only one level active because of 2 or 5. Now the bottom ones are what dictates where the flip happens and where the new part. So the first one, original position, is 0, which is correct because we had it based on the WCS. So the first one was at 0. This next one, we're going to transfer to -0.375. And what that basically means is the WCS of the flip part is going to be the back face where that thread is, that 375 dimension. 375 on the right, so it's the length of the thread. So you see that? So that face is going to become our 0 on the flip part. And that's because when we're machining this, they're either folding or threading this into a fixture, and they're bottoming out on that 375. So that becomes 0. So they basically screw this in, it gets tight, and then that's what they basically work for. Okay. So that -375 position dictates 0. Now the other 2 are being pulled from the stock setup, the 1.5 and 4. The chuck setup, we put that -4 inches in. We're not going to modify those at all. We're just going to put those in here. So now, yeah, exactly, perfect. Yeah. So now you see if you click on the one on the left, the highlighted yellow, you see where the edge of that face is. It's at 0 basically now. Now when you go and this is the one that we copied. So this means the 0 face. If you go into levels, you can rename the second one ops 1. And then you can turn on and now see, so you got the remaining stock that you gotta machine off, it's all over there. Your Z0 is set, so you just make sure that your plane, if you go to planes right now, make sure you're still on that thing. So right now you're on top, so you want to change that. Yep. And now basically you're gonna rough and finish turn, the back half of that part. Then you, okay. And that's gonna be something that you work on, and it's right. So rough, finish. Those are the last two. All right. If you have any questions, let me know. You can basically copy the previous one. Not really. Okay, yeah. Okay, so, that. You can, oh yeah, so go ahead, file. And then replace. And then go to the, I'm not gonna do that. All right. And now. So if you put that in. Or just waiting for. Yeah, that's more what I meant. Yeah, so I literally meant the fall places, but in that. So so you could have done that before. So that's not works. But you can follow, you saw what I did, right? Yeah. You can walk me through it if you got it. Okay. Yeah, go for it. Yep. You said, are you using it? Yeah. So if you try to regenerate the wave, it looks like the stock. Oh, wait, I just stock. Delete that stock. Just look at all. So let's go on the property. And then stop that. Your plane, so the property is stock on. Okay, so this is good. Okay, here. Let's go with this. Okay, so this is just okay. So you just define, so 1.5 is the diameter that we're holding. And our knee position is -4. And that should get most. So that's the struck out. Now we generate everything that's on it. If you just select the one, you can just go. Up one. So now go to lane and just go to computer. Yeah, just hit equals. And then double click. So that's what you want. All right. So now you need a new toolpath group and then the stock group, which I don't think was right. So what you got is the toolpath. So you make a new toolpath by right clicking. Use toolpath. And, now you can, yeah, you got your, I'm gonna put this thing on the screen real quick, because I want one of the questions, that's right. But I think you've got all of that, well, you heard me talk a little.
I had that, it did that, good job.
Okay, so grab, down. You will need to select. You shouldn't have. Now, so you do have an issue with your pin stock though, and this is going to be one. And this should. And you shouldn't. Mind that. Yeah. Okay. So something's going on with your stock though. One year, senior roughly. So I guess you see this, I think there's been, probably has, still has. Break one parameter, but I don't think they modified the change. So, I should have had you what I wanted to do to the top here. And I had to do it. So really, set it all the way over. You see how it kind of dives down. That. For the rub, yep, which was good. That's fine. That's good. Oh. You have two left. So what is it here? Now. So yeah, so now you. And then put it down on that. Your finished tab was hung up with sockets and stuff, so I think by changing one of it, kind of regenerated it. And that's the socket. So now you can start that up. I'm just gonna run to the restroom real quick. I'm morning and I can sit down. Just look at it.
So there was a couple of setup things that we did. And how this works. So that's good.
Okay.
This is fresh file. Or do you have one? Okay, that's fine. We'll have to regenerate all those.
Mhm. Yeah, I changed it,
Okay, so if you just select the machine group 1
yeah.
and then go up to regenerate during toolpath switches. The fourth one from the left in the first row. Yeah. That's okay? Just try to keep it on. Okay, so a couple of them. So let's go to stock setup. I think that's where most people should. So that's good. Properties. So the OZ should be 1.5.
Oh, under 4, negative.
That's a 0. Actually, put a 0 on later. And then the length here is 1.6. And the right hand margin is 1.2. So that's your basic.
0.02,
Yeah, 0.02.
that's margin.
Nothing on that.
Okay.
So you can exit that. And then Chuck Jaws. And parameters. So now the unit defined position on diameter is 1.5. Because that is more stock. And the Z position here is -4. So that's the Chuck position measure. Now that should fix most of the stuff. Okay, so they
Probably I did wrong.
stock.
Oh. Doesn't work, right?
Mhm.
So,
Can you go to your plane? Okay, so hit the equals button on that, so we're raising it on. Now go to your tool tab. Okay.
where's left to the right?
Oh, go back to stock setup. I think. Stock. Change the drop down. Stock.
Okay. Oh, well, it's 6 delayed. Oh, no. It's there. So funny.
Do you have? Can you show me your stock? Let's know what levels is on there. All right, now I think I know why. I did that on that. Close that or find that. We want the option. So why don't you rename that? That should be option. Now go back to tool tab and drag the red insert flag up to the top and actually drag it all the way down the bottom of, yeah, and now try to read that. Okay, that's fine. All right, so let's open Lazy Page. But then use stock. And that should be yeah, that finish Z number should be 0. That's why that's correct. That was because your stock would be more. Yes, Saturday should figure that out. So that's fixture Z. So now the cutoff, same deal.
Oh, I have to create them, the C-axis, number 5. So I need to pull this guy in here, this create the C axis.
We can do that.
Yeah.
Let's fix the cutoff
Yeah,
first.
okay.
So let's just go in there and go to.
I think the geometry, I made it wrong.
Okay, so the
Let's cut off.
geometry should just be the point at the end. So
So
all you need is click on the end of the part.
this one is,
No, not the very end,
yeah,
where you're parting off. Yep.
this one?
Now you go to the top of the circle. And hit escape. Okay. So I want you to try and get the top of that circle. Because you basically want to.
This
Yeah.
one, right?
Yeah.
Then,
And now go on the
enter.
parameter. And you gotta have from stock selected. Here's, so click on from stock to the entry point. And from stock to the recon. That's good. The one top.
Hmm. Okay.
Now it's gonna be calculated based on what you have. left.
Oh, and also the sheet, the item, the tool.
Oh, that's correct.
Right. I selected a wrong one.
Okay.
So I have one that is wrong. Okay.
Now, so now you got an issue with the late finish. I believe. So let's go to the late finish. Yeah, I want to see the chain on that, because
Yeah. Made a mistake.
it wasn't you, I did it, and I'm gonna fix it, so rechain all. And then it should be the bottom of that chamfer.
Yes.
Yep. And then the straight line on top.
Yeah, that guy. Okay.
No, no. Undo that. It's, and then the straight horizontal line. So before the radius, one before it. Yeah, that. And then what we did is we had it looks like you had this section. So now if you zoom out. Does your roughing, can you show me, can you run the back block? Okay, so you're roughing. Go to rough.
I think I selected the wrong, I selected one wrong.
Go to rough parameters. Where stock recognition is,
Yeah.
change that to stock. Hey, have a good week. Yep, sounds good.
Have a good night.
Take care.
You too.
That's what she looked like.
Yeah. And then just the C thingy.
Yep, yep. So to your point, you got the insert flag right
Yeah.
at the bottom. So you're gonna do C contour.
Yeah.
Contour. It's the one next to it.
Save the console.
Yeah, it gives that mirror. All right, so go to machine group and go into tool settings for files. All right, files. So the machine that we had picked in there is not, you had the lathe 2X, which can't do C-axis stuff.
So,
So hit replace.
which one?
Right.
This?
No, here's the lower. It's down the screen. Machine tool tab.
Machine to a cluster, okay, replace.
Yeah. And we're gonna pick, and that's gonna change the post. So when you click OK, now it should update everything, and now if you go up there, it'll let you.
Yeah, so, yeah,
One next to it.
base,
Yeah, space on.
then we did,
So we want to do edges only, so it's the first selection. But the one next to the, yeah.
Okay.
And then we're gonna go and look at use your mouse. And keep going to the one. You can get. So you get that.
This guy,
line right there, yeah.
and then you go this side.
Yeah, but in between, we're gonna click OK.
Oh, yes, I
So
understand, yeah,
click the green button there,
yeah. This,
yeah,
then
and then we're going to go,
again,
click OK. And then go back into the app, go back into the GM. And then add change. And then click on it. Should go here. So we want to go the other direction. So just this way.
this,
There you go.
and then go around.
Second plan. So now the tool is gonna be a half inch.
Oh, yeah, I remember,
So we gotta go on the wide tooling.
21. What was that?
The tool library is the last one. So you gotta click out of here and go into,
Live tool.
yeah, you gotta select the new library.
Lathe tooling.
Yeah, at the very top, we want live tooling.
This one?
Live, L-I-V, it's at the very top.
It should be L-I.
It's not an alphabetical order, it's you go up top. It's got that.
Oh,
Yeah.
I thought it starts from the L.
Yeah, it has a little
Okay.
squiggly.
And then finish and mill, right?
Yeah, that's okay.
Half, 21, correct?
Yeah.
And then
That's fine.
all right, and then, comment mail, the access, black, right?
Yep.
And then, that's it.
Yeah, that's good.
And I have cut parameters with big cut.
So in cut parameters, just change that to where compensation instead of computer. And start being more specific about that.
Breakthrough, you need 0.025.
Yeah. And let's go back and look at parameters, because we're gonna do the extension now while we're here. Or I'm sorry, on that one.
Yes,
We didn't do that one.
read and read out, yeah, read and, yeah, I have it here.
Turn the two bottom ones on for adjust.
Adjust, yes, length, what was it, we did 10?
I think it was more than that. That's why it's fun.
This was week 10.
50,000. Yes, this is week 10, yeah.
0.05?
0.05, yeah. And you guys.
Yeah, there was a 10%.
10%, yeah.
And then push it to the right.
You got it.
Yeah.
Now you want to extend them and not short.
10. Okay. On the key parameters,
So everything should be absolutely.
then are we still doing the return quarter or
You can do a quarter, sure, yeah.
clearance?
No, that one, we don't give you that far
Okay,
out.
all right.
No.
Sibling, same,
Same, they do quarter inch there.
then top of stock,
So your top of stock is the start of is basically the start of a cut on the right hand side.
Yeah.
So it's the same line that you just picked for that chain. That's good. Yeah, even if that radius is fine.
this,
Yeah, it should be 335.
yeah, and then go
And
to
then
the
your
other
depth
side,
is gonna be the back part of it. No, it's gonna be the back part of that.
this guy here.
Yeah, because you're looking at it the same way the tool's gonna be. So you're in line with the axis. So that should be -5.
Yeah, negative 0.5.
Good, yeah.
Lane, coolant, you want on,
Yeah.
good. Yeah. Right, late. And you wanna do the, verify, right?
Backslide usually. You can run the verify if you want, so you get more than backslide.
Okay. That's good.
Yeah, the back is still doing something funky, but.
Yeah, and then this one.
So you've got the same issue that I had before, so I think you need to extend your roughing path.
Where's that in the later on? Then,
So,
then,
yeah, so you did it at the start of the contour, you want to do it out.
oh,
Wrong, yeah,
yeah.
it's a fairly small.
What, 2.2?
0.2, and then do that in the same path. There you go.
Yeah.
So that would get rid of that.
Should be good now, right?
Yep. And now you're ready to rust and.
Same with this, yeah, okay, so now I'm, all right, thank you.
You're welcome.
Are you still with me, Matt? How you doing?
Still awake.
That's cool. You walking through it okay?
Yeah, when I did the flip over, something happened and I lost everything that I had done. So
Okay, so if you go back in there, there's a box that says blank geometry. You got to
Mhm.
make sure you uncheck that before you flip. That's
Yeah.
probably what happened. Okay.
all right, I'll remember that. Right now,
You
I'm
should
just
be able to get back though. Like if you deleted that toolpath, I think it comes back. Don't
yeah,
quote me on
I
that.
wasn't able to get it back, but I mean, we didn't do all that much, so I'm just regenerating.
Okay. Yeah, once you get used to it, you can walk through this pretty quick. I think I did it in like 15, 20 minutes last night. So
Yeah, so it really isn't that bad.
yeah. Yeah, there'll be some more C-axis stuff. The face contour is easy. The C-axis contour stuff is a little bit more difficult because then you start working with surfaces and it gets kind of picky.
Yeah,
But the contour stuff is easy.
yeah. So you're gonna post this video?
I will, yeah. I'm probably going to kill it now, I think. I probably should have killed it a while ago, but
Good.
yeah, I'll do that right now and I'll upload it probably, I'll probably have time to do it tomorrow, I think.
All right, sounds good.